This is the Math 2 lesson summary video for the lesson titled Building a Perfect Square. The purpose of this lesson is to develop an understanding of how to complete the square using an area model. We are introduced to Optima in this lesson, and we are told that she has a quilt shop where she designs quilt blocks. She bases her designs on quilt squares, where she calls the length of a basic square x and the area of a square x squared. We explored in number 1 that she adds 3 inches to each side of her square. She would be designing a square with an x plus 3 side length. Therefore, we can write that as the quantity x plus 3 to the power of 2, or x plus 3 squared. We are then asked to use the diagram provided and the equation of a of x to explain why the area of the quilt block can also be written as x squared plus 6x plus 9. If we refer to the diagram, we can determine that this is an x by x square, so the area of the square in the bottom left is x squared. Each rectangle represents a length of x by 1, so each rectangle has an area of 1x. So the area of the entire diagram would be x squared plus, we have 6 x's, and we have a 3 by 3, 9 constants. So we can write the area as x squared plus 6x plus 9. We can relate that to x plus 3 because each side length has an x and 3 ones. So we can say that each side has an x plus 3 length. We are then given a square with a side length of x plus 2. And we are asked to draw a diagram and create an equivalent representation for the area of this square. Since the side length is x plus 2, we need to find how many small constant squares we need to add in the corner to make a perfect square. We can place each constant square in the corner. There's 1, 2, 3, and 4. And see that we would need to add 4 of these green squares to make a perfect square. Therefore, an equivalent form for the area of the square of an x plus 2 squared would be x squared plus 4x's plus 4. In 6, we are told that Clementine the dog ate up part of the quilt orders, and we are asked to determine the missing value of each expression that would find the appropriate area to create a perfect square. So we are trying to find these missing values on the end of the orders. If we take a look at the expression in 6b, we can see that we would need to add 9 green squares to make a perfect square. Keep in mind this is an x by x, an x squared area, and we have 6 total x's. And we would need to add these constant squares to make it a perfect square. As you notice, 3, 6, and we will need 9 constant squares added to the bottom to complete this square. Therefore, our equivalent expression should be x squared plus 6x plus 9. Moving along to 6d, we are now also still asked to find the missing order that Clementine ate up. If we are asked to complete this square, we would need to add 36 green squares in order to make a perfect square. I can keep moving these green squares to visually show you that, but we know this is a 6 by 6 square or 36 little squares. In 7, we then concluded what relationship we noticed between B and C. After examining several cases, we noticed that if we divide B by 2 and square it, this will always equal our C value. For example, in 6D, if we take 12 and divide it by 2 and square it, we would get 6 squared, which does give us 36, which was our C value. Then we are asked, well, what if B is negative? If B is negative, let's say we are provided the equation x squared minus 4x, and we need to find C. If we apply the same rule, B is negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. When we square it, we will get 4. So that does work when B is negative. In cases where it is an odd number, let's say we are provided with the expression x squared plus 3x, and we need to create a perfect square. We would divide 3 in half and square it. So we would get 1.5 squared to obtain 2.25. The perfect square would be x squared plus 3x plus 2.25. This also works when B is odd. To summarize, we now know that we can create a perfect square without algebra tiles if we use the rule that B divided by 2 squared will always equal C. This strategy will always help us find a perfect square. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.